We've already seen some examples of equations that include squared terms, where the highest order term is a square. These equations behave in a particular way, and we call them quadratic equations. They have some pretty interesting characteristics.
Here's a quadratic equation in which y is equal to 2x squared plus x minus 3. Now if we plot the line for this equation, it forms a parabola, which is characteristic of quadratic equations. In this case, the parabola is open at the top and it closes at the bottom. Well, here's a similar quadratic equation, but this time the x squared term is a negative value. And when we plot this equation, we still get a parabola, but this time it's open at the bottom and it's closed at the top. Now the point at which the parabola reaches its maximum or minimum y value, depending on whether it's downward opening or upward opening, is called its vertex. The vertex is located at the x value of the parabola's line of symmetry. In this case, the line for the equation crosses the x-axis, and because it's a parabola, it crosses it twice, so there are two x-intercepts at the point where y equals 0. Now it's possible for the parabola not to cross the x-axis at all, and therefore have no x-intercepts, but regardless of whether it intersects the x-axis or not, for every y value there are two x values, and they're equidistant from the line of symmetry.